Hello everyone, this is Abhinav, an undergraduate student under the Department of Electronics and Communication at NIT Andhra Pradesh. In this video, I'm gonna discuss about the bisection method using C program. So let's start with the definition. The bisection method is a numerical method used to find the root of a function. It works by repeatedly bisecting an interval and selecting a subinterval in which the function changes sign and then continuing the process on the selected subinterval. So the principle behind this application is of use of intermediate value theorem, and it is also known as binary chopping or half interval. And it is one of the most simplest and most reliable iterative method for the solution of nonlinear equations. So now let's discuss about the algorithm. Let's suppose f of x equal to 0 is a nonlinear function, and it is a continuous function defined on a and b interval. Also, f of a and f of b has different signs. Then that is the f of a dot f of b is less than 0. So to find the minimal or optimized root, we have to find the midpoint first. The midpoint of the interval a and b, that is c1 equal to a plus b by 2. So if f of c1 equal to 0 or modulus of f of c1 is less than epsilon naught, where epsilon naught is the absolute error or the tolerance, then that c1 is the root. If it is not, that is f of c1 is not equal to 0 or modulus of f of c1 is greater than not or greater than or not greater than or equal to epsilon naught, then find the region of the opposite sign. That is, we have to find the opposite sign region. So how to find the opposite sign region? So it is there that we have to find the multiplication of f of c1 into f of a. If it is the product of f of c1 and f of a is less than 0, then it is region of opposite sign. That is, then the c2, that is the midpoint of c1 and a will be a plus c1 by 2. And if it is not, that is, then the f of c1, product of f of c1 into f of b should be less than 0. Then it is region of opposite sign, that is c2 equal to c1 plus b by 2. Then again, we have to find the function value at c2, that is f of c2 equal to 0. Or if f of modulus of f of c2 is less than epsilon naught, it means that the c2 is the root. If not, then we have to find that at the next region of the opposite sign. So then again, we will be repeating this process, and after iteration, we have to find the root. We have to iterate until we will get the root. That is, either it should be equal to 0 or the modulus of C2 should be less than epsilon naught. So this is the graphical representation, and from this is the starting where A1 and B1. Then we have to find the midpoint, that is A1 plus B1 by 2. Then the midpoint, from the midpoint, we will be starting again f of A2 and f of B2 find, then the midpoint, then f of A3 and f of B2. Then through that we will find this value, that is optimized value. So now let's do this equation. That is, using bisection method, we have to find the root of this equation, x cube minus 2x minus 5 equal to 0, where epsilon naught is given as 10 raised to minus 4. That is, we have to find the correct up to 4 decimal places. So this is the code written in the C program. So initially, we have defined the function, that is x cube minus 2x minus 5, and we also defined this function, that is bisect of x1 plus x2 by 2, find the midpoint. Then we started the iteration of I equal to 1, and these are the float values, that is x1, x2, x3, the x. Then we will ask the number of maximum, enter the maximum number of iterations from the users, and users have to put the iterations and the boundary points, that is starting boundary, that is a and b in that previous algorithm. Similarly here, x1 and x2. So then the find value into, that is x1 into x2. If the in this equation, the function will take this value from x1 and x2, and it will put that if function of x1 and function of x2 is greater than 0, then it means that both are of opposite sign, both are of same sign. It means that roots are invalid. And if both are of different sign, that is else, the roots lie between the function, that is x1 and x2. Then we will be doing the bisecting this x equal to bisect, that is the midpoint is the x, that is x1 plus x2 by 2. And then we'll be again doing this f of x1 and f of x2 is less than 0, and x2, then x2 will be x, else x1 equal to x. Then again the bisecting this value x1 and x2. Then if that is absolute value of this is less than epsilon, we are checking the value of the epsilon. Epsilon is already defined here. There we have all, you can see here where we have already defined the epsilon value that is up to 4 decimal 0.0001. The same thing is here, that is the absolute value of x3 minus x, that is less than, then we got the root, that is we are printing the root, that is total iteration is given and the root is also returned. If not, we will be again iterating up to finding the root. So these were the initial value, that is x1 equal to 2, x2 equal to 3, the midpoint 2.5, and we didn't get, we find the opposite sign region, then again doing this, iterating again and again up to 14 times. We got the x values this and f of x values this. So this is actually the up to toleration of 10 raised to minus 4, right? So suppose we give the maximum number of iterations 4, and we have the user also input that x1 and x2 as 2 and 3. Then it will be the code will run and it's shown the iterations 1, 2, 3, 4, and all those roots and respective roots, and the final value number of 4 and the roots also shown. And suppose if we gave up to 15, the maximum number of iterations is 15, and the initial roots are 2 and 3 is given initial boundary values, that is 2 and 3, x1 and x2, then it means that the roots lies between 2 and 3, right? And it is also returned, and all the values up to 15, all the roots and intermediate roots means, and also the final value is also returned, that is 2.094604, and total number of iterations, that is 13 times iterated. Because why 13? Because after 14, we got the answer at 13 itself. No need to up to 15 times. So now let's move to discuss about the advantages and disadvantages. So what is the main advantages is, it does not have to, we do not need the knowledge of the derivative functions and all those steps. Only one function evaluation per iteration. And what's the disadvantage? It takes a lot of time, slow to converge, and sometimes good intermediate approximation may be discarded. Now let's move to the application. I have created an application, use of this in an application, that is thermistor, where we will find the temperature value. So this is a thermistor. Is what's a thermistor? It's just nothing but a type of resistor whose resistance changes with the temperature. The relation between the resistance and the temperature is given by Steinhart equation. Steinhart equation, that is 1 by t equal to a plus b ln of r plus c ln of r cube, where t is the temperature in Kelvin and r is the resistance in ohms, and the rest a, b, c are the specific constants to be the thermistors. So this is the algorithm for that. How easy we have done is this: define the values for the thermistor resistance at nominal temperature and beta value. Then the step 2, we have to define the analog input pin that the thermistor is connected to. Then in the third steps, we have to create a function that takes an IDC value as input. In the fourth steps, we have to convert ADC value to the voltage using this formula, that is V output equal to ADC into 5 upon 1023. And then we have to calculate the thermistor resistance using the voltage divider formula. It is also given. Then we have to again calculate the inverse of the temperature using the Steinhart equation. Steinhart equation is 1 by t equal to 1 by t naught plus 1 by d ln of r upon r naught. And in the then again we have to convert the inverse of the temperature to the temperature in Celsius using the formula. This is, as everybody knows this, right? So then we have to return the temperature to Celsius. Then in the fifth step, we call the function with 6 different ADC values to test it and print the calculated temperature for each test case to the console. Then we will end the program. So let's see the code. So this is the code which is also written in the C program. And we have also already initially we have defined all the values of thermistor, that is R0, T0, beta value, pin of the thermistor node, and all these things. That is resistance and nominal temperature, what is normal temperature, then beta, then analog input pin, and all those things. And we have provided this. This is the value we have to find this R, and then R is equal to, already know that 5 into thermistor R0, that is the resistance and nominal temperature, divided by 5 minus V output minus thermistor of, that is the R0, that is this resistance at nominal temperature. So then convert resistance to temperature using Steinhart equation. Then we will be testing. This is the test one, where ADC value of 0 should give minus 273.15 degrees Celsius. Then test case 2, again like this, up to test case 6, we have the ADC value of 800 should give a negative temperature. And it is failed. Know that ADC value of 600 should give 72.27 degrees Celsius, like this. Why this is test 6? It's failed because the sixth test case should fail because the ADC value of 800 corresponds to a resistance that is outside the valid range of the Steinhardt equation. So when the resistance is too low or too high, the Steinhardt equation can produce negative temperature or temperatures that are far outside the expected range. In this case, the calculated temperature is likely to be invalid or meaningless. So therefore, it's important to make sure that the thermistor is operating within its valid range. It's also important to check the results of the calculation to ensure that they make sense. So this is all about the bisection method. Thank you.